Okay, so I've been willing to do this to compare the solver optimization software in a process simulation software and with a typical simplex solver. Yeah. So we're going to use the this well-known refinery production planning, which you can do basically whatever you want. So the basic is that we have two different raw materials, in this case crude, with two different prices. One is then cheaper, the other one is more expensive, and we can either we can send either one of them to the refinery or both of them to the same plant, basically, and you can then create different products with these yields, right? So this different, whatever, for example, this gasoline. So if you put like crude one, you will get like 80% of that crude one into gasoline fraction, into these fractions, and the same goes with crude two. Will then create 44 percent volume of gasoline if you use crude two. And then each of these products, they come with the prices, right? So we can see the prices, and then the different crudes with all different raw materials, they have different properties and then the different concentrations. Hence, the processing cost will be also be different. Like in this case, crude one is like half of the crude two. And then for each of the products, depending on the unit configurations of the plants that you have, the limit, the equipment limit for each of these products, they have some numbers here. So we can only make like a 24 kilo barrel per day, for example, in this case for gasoline, and then 2 kbd for kerosene and 6 for fuel oil. So the model is very simple basically. So if we objective function, then obviously to maximize the profit, which means we calculate the income, how much then the income or revenue, which is then the and then minus raw material cost, right? And then minus the processing cost. So the income, as you know, is just like the amount of flow rate of the products and then multiplied by its product price, like in this case, and then you sum all of them. And then the raw material cost is on the opposite side. So we sum all of these, the amount of crude that we use, and then multiply by its crude price, and then processing cost as well, the amount of crude or materials in it, and then we multiply by the processing cost. The question is then how much is then each of these crude? Either this is like a number or that number, or we use one of them or both of them. So we put the first constraint, which is in this case we know the amount of products, right? So if we know the amount of crude and then multiply by the yield, and then we can get the amount of product, and then this has to be like equal product flow, and then this product flow will be should be less than this number, okay? And then the both of these variables, the crude flow, which we don't know, which we want to find out, is has to be like a zero or positive number, while the amount of product has to be also positive number. So if I code this into Symmetry, right? So Symmetry has this spreadsheet process calculator, um, and then the price, the flow rate, which I put like initial value, and then calculate the code cost. Same goes the same table over here, and then the maximum products, which I put in the number, and then I calculate the processing cost, calculate the crude cost, calculate the revenue, and then calculate the profits, right? So which is with this one crude two one and one crude two, and then I go to the optimizer. So I preset this so that it's faster, and well, we know process simulation is not meant for this type of optimization, but I'm just really curious to see. So maximizing the profit. What are the variables? Code one and code two. What are the constraints? The maximum flow rate of these three products. Residues, there's no maximum flow rate. So if I here we have like a settings. We can see there are a number of solver, right? It's a lot, but most of them they don't specifically design to deal with this type of linear programming. So if I put like Powell, for example, I get something like this. If I run this one, I use Powell, and I run this using, and then I get 282.75. Um, this is not the actual number yet. Yeah, I forgot to mention what the actual result is. But nonetheless, this is then the optimized value. So we need to have like 26 of code one and then 6 code two. and then the gasoline hitting the constraint, kerosene almost hitting the constraint, while in fact in the actual solver these two are constraints, right? So it has to be like 2. And then if I change it, so it's not really that powerful in this experiment. So I change it to like power interior point. So it's about the same. It's even it was 286, right? And then this is not really even close, 191. So it's not really that fun. So I use that GLPK solver in Python, and then I put like this Streamlit stuff. So if I have like um, input with the same input file, and then we can see the crude one is this in the price, then the price, and then the processing cost, and then the product, the price, and also the maximum number. So I put this residue because residue is not like a constraint, so I put like a dummy high number, and then the yields of crude one for every product, and then crude two for every product, but the same yield, which is basically in this Excel file. So as an input, so in all practical reality, you can create all kinds of codes, and then the price, and then processing cost, and then all types of products price, and then the maximum production, and then the yield. This is something that you have to create in this manner. Okay, so you can basically expand this into any type of processing plants, for any type of raw materials and products, as long as you have all of these basic numbers. So coming back to this one, so if we optimize using this GLPK, and then it gives us this one. So 26.2 for crude 1, and then 6.89 for crude 2, 286.75, uh, which is then the correct number. So which is, I mean, this Powell is not even, sorry, this IPOP is not even close, but if you use Powell, because it seemed to be like a closer, you can try to use all the other software, solver, so we can see 282, while in fact you can go up until 286 by using 26.5 crude 1, while in this case 26.2 crude 1, and then close to 7.9 for crude 2, which in this case only 7.2 for crude 2. So well, Powell comes very close, while in this case this is then the actual results. Yeah, as you can see in my other videos about the refinery or linear programming videos. Okay, I think that's it. So I'm now satisfied with the performance. As I can now see the difference in the performance for the solver in the process simulation software compared to the open source linear programming software. Okay, that's it now. Bye bye.